In this video, we'll look at rational expressions and equations. So a rational expression is a fraction that's made up of polynomials. And we can simplify these by factoring them and then canceling out any common factors that they have between them. So if we look at an example here, if we have x squared minus 9 on the top, and on the bottom, we have x squared minus x minus 6, how can we simplify this? The first step is to factor both the numerator and the denominator here. So on the top, we have a difference of 2 squares. We have x squared, we have 9, and we're subtracting difference of 2 squares. So we can say that the top is x plus 3, x minus 3. And then on the bottom, x squared minus x minus 6. We can simplify this to x minus 3, x plus 2. Now, like I said, we can simplify this by factoring and then canceling out any common factors, any common terms that they have between them. Well, I see that both of these terms have an x minus 3. So we can cancel that out. And then we can rewrite this as x plus 3 over x plus 2, which is as simplified as we can get for this rational expression. Let's do another one right underneath it. If we have x squared plus 5x plus 6 on the top, and then we divide it by x squared plus 7x plus 10, let's see how we can simplify this. So we can rearrange the top to be x plus 2 times x plus 3. And then on the bottom, we can factor this and get x plus 2 and x plus 5. So all we're doing here is we're factoring. We're trying to figure out what number multiplies to equal 6 but adds to equal 5. So in this case, it's 2 and 3. On the bottom, what number multiplies to equal 10? What adds to equal 7? It's going to be 2 and 5 together. So now we can look at any common terms. Well, I see an x plus 2 here and an x plus 2 here, so we can cancel both of those terms out. If they're on the top and the bottom, we could just cancel them out. So our final answer is going to be x plus 3 over x plus 5. And that's as simplified as we can get. Well, what happens if we multiply rational expressions together? So if we have 2x over x squared minus 1, and we multiply that with x plus 1 over 3, it is possible to actually do this multiplication, end up with one fraction, and then solve from there. But there's a much easier way we can do this. We can factor this denominator down here on the left, and then see if it cancels out with this term up here. So if we have x squared minus 1, that simplifies to x plus 1, x minus 1. And since we're multiplying it by x plus 1 over 3, we see that on the bottom we have an x plus 1, and the top we have an x plus 1, which then cancel out. So now we have only 2x on the top, and then on the bottom we have a 3 times an x minus 1 as our final answer. So when we're multiplying, we can factor everything out first and then cancel any common factors and then multiply straight across from there. Let's look at another one on the right side. If we have x to the second minus 4 divided by x plus 2, and we multiply this by 1 over x minus 2. Let's see what we can do here. Well, we have a difference of 2 squares in our first term in the numerator. So I'm going to write right underneath. And we can say that this is x plus 2, x minus 2, over x plus 2. And this is multiplied by 1 over x minus 2. Let's see what we can cancel out on the tops and the bottoms. So we have an x plus 2 here on the top. We have an x plus 2 here on the bottom. We can cancel those out. we have an x minus 2 here on the top and an x minus 2 here on the bottom. We can cancel those out as well. So when we cancel things out, they essentially get replaced with 1 because when we're multiplying, 1 doesn't really change anything. So our final answer is just going to be 1 over 1, which is just 1. Now what happens if instead of multiplying these rational expressions, we are dividing them? If we have x squared minus 1 over x plus 2 divided by x minus 1 over x plus 2. Let's say this is our example. Well, what we can do is we can think of the phrase keep, switch, flip. That's what happens when we are dividing by fractions. So this means we're going to keep the first term just as it is. We could rewrite it here. Switch the division to a multiplication sign, and then flip. That third term we're going to flip and put the numerator on the denominator side, the denominator on the numerator side. So when we flip it, we get x plus 2 on the top, and then x minus 1 on the bottom. Now we have a similar example to one that we saw before, where we're just multiplying these expressions together. So now we can do exactly what we did before, and we can factor anything that we can. So we can factor this very first term on the top left, and that'll give us x minus 1 times x plus 1 over x plus 2. We're going to multiply it by x plus 2 over x minus 1. Let's see what we can cancel out here now. We have an x plus 2 on the bottom and an x plus 2 here on the top. So we can cancel those out. We also have an x minus 1 here and an x minus 1 here. We can cancel those out as well. So the only factor that we're left with is this x plus 1 that we have. So that's going to be our final answer. All this simplifies to just x plus 1. If we were to look at another one, we'll have x squared plus x over x squared minus x, and then we're going to divide this by x over x minus 1. Let's see what we can do here. Well, we don't have a difference of two squares like we did before, or a trinomial that we can easily just factor out. But what we can do is, if you look at our very first term, we have an x everywhere. So we can factor an x out. So we can rewrite this first term as x plus 1. And then the bottom will be x minus 1. So since there were two x's in the x squared, there's two x's, we're taking one out. There's still one x there. And then that plus x and the minus x, that's the only x, and we're pulling it out. So it's just replacing it with a 1. And then instead of dividing it by it, we can do our keep, switch, flip method and multiply it by the flipped fraction, x over 1 over x. Now let's see if we can cancel anything out. So the very first thing I see is we took out an x out of both terms, so we can cancel that out, an x on the top and x on the bottom. After that, I see an x minus 1 here on the bottom and an x minus 1 here on the top. We can cancel those out as well. So all we're left with, if we rewrite it, is x plus 1 over x. Now we can't cancel these two x's out because this term x plus 1, that 1 would also need an x. Since not every term in this fraction has that x, we can't cancel it out. So this would be our final answer, x plus 1 over x. Let's look at some examples that typically mess students up when we're working with rational expressions. This is adding and subtracting rational expressions. So if we have something like 1 over x plus 2 over x, our regular fraction rules are going to apply here. If we have the same denominator, then we just add the numerators together and keep the same denominator. So this is 3 over x. But a lot of times we won't have the same denominator. So if we have something like 1 over x plus 1 over x plus 1. These are not the same denominators, so we can't add these together. The only way we can add them is if we get them to have the same denominator. So what we can do here is to find a common denominator. Typically what that means is you can just multiply the two denominators by each other, and then that'll be the common denominator. See how you can get to that common denominator from where you're at. So if I work over here and do x times x plus 1, I will end up with x squared plus x. So that's my common denominator, x squared plus x. I just have to figure out how to get there. In my first term, I have an x in the denominator already. Well, what did I do with that x back up here? I multiplied it by x plus 1. So that's what I'm going to do here. I'm going to multiply the top and the bottom by x plus 1. So if I multiply the top by x plus 1, I'll just get x plus 1. And then the bottom, I'll get my x times x plus 1. And then if I look at my second term now, I have x plus 1 as the denominator. Well, what did I do here with x plus 1? I multiplied it by x. So that's what I'm going to do in the second term. If I multiply the top by x, I'll just get an x. If I multiply the bottom, I'll get the same denominator that I have in the first term, x times x plus 1, which is exactly what I want. Now we have the exact same denominator for both terms, and we can add these together. So we're going to keep the same denominator as x times x plus 1, and then we're just going to add the numerators. We're going to have x plus 1 plus x, which I could just rewrite to 2x plus 1 being my final answer. So this works when we have any two different denominators. So if we have 2 over x minus 3, and we add it together with, say, 3 over x minus 2. Well, how can we get this common denominator? Well, we could just multiply these together. We'll have x minus 3 times x minus 2. This will give us some polynomial. But we know that this will be a common denominator. Well, how do I get to that polynomial in my first term? Well, I took my x minus 3, I multiplied it by x minus 2. So that's what we're going to do to the top and the bottom. So on the top is going to be 2 times x minus 2. So I'll just say that's 2x minus 4 over our common denominator of x minus 3, x minus 2. And then we're adding that to, how do we get the common denominator for the second term? Well, we have x minus 2. How do we get to that common denominator? We multiply by x minus 3. So that's what we're going to do here. 3 times x minus 3 is going to be 3x minus 9. And then on the bottom, we'll have our common denominator of x minus 3, x minus 2. So now in our simplified answer, we'll have x minus 3, x minus 2. And then on the top, we'll just add them like normal. 2x plus 3x is 5x. And then negative 4 plus negative 9 is negative 13 as our final answer. If we were to do subtraction, it would be the exact same way, except instead of adding here at the end, we would just subtract. So if we change this to a subtraction sign for both terms, our answer would be 2x minus 3x, so our answer would be negative 1x, negative 4 plus 9 is going to be plus 5. So that's what our answer would look like if this were a subtraction problem instead of addition. So you would do it the exact same way, except at the very end, when you are adding the numerators, instead you would just subtract the numerators. So up until this point, we've only talked about rational expressions, but now let's get into solving rational equations. So this is when we have an equal sign, we are going to get x or whatever variable equals some number. If we have 2 over x equals 3 over x plus 1, how can we figure out what x is equal to? Well, here we're going to take advantage of cross multiplication. So that means we're going to take the top of one term, multiply it by the bottom of the other term. Take the other top term, multiply it by the bottom of the other term, set them equal to each other. So here we would do 2 times x plus 1. So I'll just say that's 2x plus 2. Set that equal to the other cross multiplication of x times 3, which is just 3x. Now we just solve for x algebraically. We'll end up with a minus 2x minus 2x. We'll have x equals 2 as our final answer here. So if they're equal to each other, we can use cross multiplication to get rid of those fractions, and then we just solve algebraically. So if we have something like x plus 1 over x equals 2 over x minus 1, let's see how we would solve this one. We would again do our cross multiplication, and we would end up with x times 2, which is 2x, equal to x plus 1 times x minus 1. So if we further simplify it, we get 2x equals x squared minus 2x minus 1. Now we can subtract 2x from both sides, and then we get 0 equals x squared minus 4x minus 1. We have to think, are there any numbers that multiply to equal -1, add to equal -4? They're not going to be friendly numbers, so here we would just use the quadratic formula, which again is -b plus minus square root of b squared minus 4ac over 2a. We have our a term, our b term, our c term. So we're going to plug this in. -4 plus minus the square root of b squared, that's a -4 squared, which is 16, minus 4 times a, which is just 1, times c, which is -1, all over 2 times a is 1, so it's just over 2. Okay. I just moved it so we have a little bit more room. So on the outside here, this -4 will just end up being 4 plus or minus the square root of 16 minus 4 times 1 times -1. Well, 4 times 1 times -1 is -4. 16 minus -4 is 16 plus 4, which is 20, over 2. Which further simplifies to 4 plus minus square root of 20 is 4.47 over 2. We're going to do 4 plus 4.47 and then divide it by 2, which gives us 4.23. Or we're going to do 4 minus 4.47 and then divide that number by 2, and that gives us -0.235. So even though these numbers weren't friendly at all, we were still able to do cross multiplication and then use some algebraic formula to figure out what x is equal to. So very briefly, I also wanted to mention what excluded values and restrictions were in the terms of rational expressions. So excluded values or restrictions are basically numbers that x is not allowed to be, because then we wouldn't get a real number for it. So if we have x minus 1 over x squared minus 4, we have to think, what numbers would we have to plug in for x to not get a real number? Well, in this case, the only thing that wouldn't be a real number is if our denominator was 0. We can't have whatever numerator over a 0 denominator. That wouldn't give us a real number. So now we have to think, what numbers do we have to plug in for x for our overall answer to be 0? Well, if we plug in a 2 or a -2, we would get a 0 here, because 2 squared minus 4 is 0. -2 squared is still 4, minus 4 is 0. We can do this with anything by setting the denominator equal to 0. And if we have any variable in the denominator, this is when it would apply. If we have just a number in the denominator, this wouldn't apply. But since we have a variable, there is going to be a number in here that gives us a 0 answer, which we can't have. So if we set this equal to 0, we'll end up with x squared equals 4 after we add 4 to both sides. Square root both sides, we get x equals plus minus 2. We cannot have our x equaling plus or minus 2 because then we would get a 0 in the denominator.